Thanks everyone for joining. My name is Mike Tilburg, and I'm a manager of software development at AEM as a cloud service at Adobe. And I am pleased to be joined by Ian Boston, who is a principal scientist, also with AEM as a cloud service at Adobe. And today what we're going to do is we're going to talk about content delivery with cloud services. What I'll do first is go through a quick introduction to content delivery and cloud services. I have a demo for you to show you how fast everything actually is. And then what Ian and I would like to do is go through and give you some tips for success and how we can really tune AEM to meet your needs. And then finally, we'll open it up for questions. Okay, let's get started. So I want to start off with a little bit of a story. And this is a scenario that I think we can all relate to. And this was something that happened to me a couple of days ago. I was sort of searching something on the web, trying to buy something that normally could have bought in a store, which I think is the state that we're all in right now, searching for everything online. But I went to my favorite search engine and did my search and clicked on one of the links and opened it up. And the site's, it really tried. It was trying to open, parts of it were coming up. But not the whole thing, and eventually I got impatient. I gave up. I closed the tab and went to the next result on the search. So what actually just happened here? So the site that I had originally gone to really missed out on an opportunity for a conversion or for getting a new customer or some business. And so basically, what I kind of feel is that I'm a fairly patient person. But in this case, and by what we have found in this article by the New York Times that came out a couple of years ago, is that we as, in general, are not very patient when it comes to browsing the web. Now, in this article, they are citing some studies done by both Microsoft and Google, and where Microsoft actually says a difference of as little as 250 milliseconds can give you a competitive advantage. And Google was saying something similar in that a difference of 400 milliseconds is unconsciously influencing the way that we surf the web. So even though I've kind of felt like I'm pretty patient, it turns out that we really aren't very patient. So what we'd like to do over the next half hour is really explore how AEM as a cloud service is going to enable you to deliver your experience very fast. And we're going to be able to do this really out of the box. So let's start by looking at a typical AEM deployment. And I'm going to compare this to some legacy AEM deployments into the cloud service version of it. So at its roots, AEM is still fairly similar in that you're going to author some content. There's an author, say, sitting in North America. And you're going to publish this to a series of publishers that are distributed in data centers around the world. So you may have some publishers sitting in North America, there's another one in Europe, and maybe a couple in APAC, one in Singapore, one maybe in Sydney. Now, these publishers also have, along with it, a dispatcher that is going to hold the materialized view for this content. And that brings the content, the materialized view of that content, much closer to the user. So let's say there's a user sitting in Perth on the west coast of Australia, and they're trying to access your site. They don't have to go all the way back to North America to get that content and all the latency that comes along with that. It'll be much quicker for them to come from either Singapore or Sydney. So while that is really good, what we've done for cloud service is we've added an entire caching layer on top of the infrastructure. And this is what is with a series of POP servers, which you can see right there in the diagram. And that allows us to cache the content much closer to the user. So now the same user that is in Perth that is trying to access the content will get the cache view that is in a server much closer. And that will shave off the valuable milliseconds, which we just saw in the last slide is actually going to be pretty beneficial. So to show you those times, what I want to do is I want to break out into a quick demo. And yeah. So what I want to show you is our demo site, and this is our weekend site that is kind of, for people that have been around in AEM for a while, you probably remember Geometrics as our demo site, but this is our weekend site, the new one. And what I want to do is I want to show hitting the site from various locations around the world. So I'm going to use an online tool that will go and just try to access this site from different locations. Now, while this is running, I'm going to kind of explain what's happening here. So what I really like about this, this as a demo site is that it's actually giving you the load time for the first visit as well as repeat visits. And that really allows us to show the difference between getting a non-cached version and a cached version. Now, because our weekend site is a demo site and we're not getting a tremendous amount of traffic to that site, there's a very good chance that the cached version is not already sitting on one of these POP servers. So you can really see the difference between what happens, when or how long it takes to get from the origin as opposed to getting from one of the POP servers, and it's pretty dramatic actually. And even in some of these locations where we're talking about a little bit less than a second, if we go back to those first slides and those studies from Microsoft and Google, that actually turns into many times of an advantage that you can get. So let's go back into the slides. And what I want to do here, now that we know how that works, or how fast it works, what I want to do now is hand over to Ian, who is going to show us a little bit under the hood about the caching topology.
Hi there. Sorry, I was trying to answer a couple of questions come up in the, I think we'll get to later. I mean, really interesting questions. So this is our topology. It's a very simplified view of the topology. You'll notice that we have AEM instances in there with a publisher in a one-to-one pair, which allows us to do invalidation because we have consistent origin. And then further out, we have the CDN POPs. These are distributed, relatively large POPs with quite a lot of instances in and a cache there, generally in memory cache, and that allows us to deliver out. At the edge, we tend to use GeoCDN to connect the POPs to the origin, so we always get to the closest origin, and then we tend to recommend some form of GeoCDN or high availability, sorry, GeoDNS or high availability DNS at the edge to connect the client to the POP. And I think the critical thing here in this diagram is we've got some immediately consistent content between the AEM and the publisher in that materialized view that you see in the dispatcher, so that the image is on the image of the site on disk cached. And then further out, we've got an eventually consistent view of all of the content. Now that's the topology we're running with. Mike, back to you.
Great, thanks, Ian. So with that, with a little bit of a under the covers view of the topology, what we really want to focus on now is the cache ratio. And so really caching is key. So we want to get, as we were showing in the demo, we want to make sure that content is as close to the user as possible and it's available as long as possible. The key to getting the cache ratio as high as possible is that we can do all of this by configuring the dispatcher. And this is all done through self-service. You can deploy that along with your builds. And as long as you're sticking to the standard HTTP spec for caching, then most sites are going to get you within 90% of your cache ratio right out of bed. Now, the goal, of course, should be 100% cache ratio. That then, there are some special tweaks that you can do to get from 90 to 100%. But definitely, if you're going to be under 80%, then the project should take a look at what kind of headers we have set in our dispatcher config. Now, as I'm going through the next slides here, I want to point out a couple times, or in a couple places, where we were able to actually use these configurations to help one of our internal projects get from a 65, low 60s cache ratio all the way up to 99%, which they are today. And the key here is that once you've set all of these configurations in the dispatcher, that's going to change the headers. And the headers are going to be honored by the CDN on the CDN layer. So let's jump into all the goods that we have in cloud services. I'm going to start with version client libs, and this is actually something that you don't have to configure. So if you're an old AEM user and you're very familiar with ACS Commons, you know that we used to have this available within ACS Commons, where you would download it and install it into all your environments. There's some development costs, some testing costs, and these sorts of things. So we've washed all that away and we put it into the product out of the box. So for those of you that aren't really familiar with what version client libs is, I just want to show you why it's so important and why it helps our cache ratio so much. And the idea with the client lib is, of course, you have some style sheets or some JavaScript libraries that are shared across a bunch of HTML. And instead of updating this library over and over again, we're actually putting out a full new version of that library. And the version is done by, you can see in the bold there at the bottom, is a hashed value for long URL for the library. And we can actually see this in the weekend site. So this was the site that we just used for the demo. And you can see, oops, wrong way, sorry. So you can see the long URL here and the version right there in the response headers, or sorry, in the request URL. Now, I actually really recommend that you go to the site and check out the request and response headers, because you can really see how we have our caching mechanism set up, and you can see the CDN misses and all those sorts of things. The other thing I wanted to point out here is that you can see the cache control from the headers, and this is a really good example of an immutable URL, and you can see the max age there is actually quite large, and I would even argue it's not large enough. So this actually calculates out to 43 minutes. But really, I mean, for a piece of content that we know is never going to expire, and I'll explain that in the next slides, it could really be even something much higher. So let's explain what's actually going on here. And I'm going to simplify in these next diagrams just V1 and V2 instead of the long hash value. But essentially what we have is we have some content that is referencing the client libs, and we're going to go to the CDN to load the content. It's going to be a CDN miss, so we'll go all the way back to the origin to get the version of the client libs. The origin is going to respond back to the CDN. We'll cache it on the CDN and give it back to the user. This is pretty straightforward. There's a scenario. So now every time after that, we're just going to be serving this client libs from the CDN, and we don't have to go back to the origin really ever again, because we know that the next time a client libs is released, now that we have version 2, there's a completely different resource on the origin. So when we go to the CDN, there is a version 1 there already, but as far as the CDN is concerned, it's completely unrelated. It has no idea or doesn't care that there was an earlier version. It's just going to go back to the origin because it doesn't have version 2, and it will serve it just like it's brand new content, and we'll cache that one. Now we have version 1 and version 2 on the CDN, but we don't care. Nobody is referencing version 1, and then from now on, we're just going to serve version 2. This is a great example of how we've actually been able to improve your cache ratio out of the box. Nothing you have to do. What I want to touch on next is a couple scenarios where you may have to do some tweaks in order to get things right. So going back to this internal project that just went live, as we were going live, there were some escalations as projects happen, even in Adobe. One of the first ones that came in was that the project had realized that there were no images being cached on the CDN. They were always missing. And the reason for that is that we aren't caching images by default. And you might ask, well, that seems like a pretty no-brainer. Why aren't you doing that? It seems like a pretty quick win. And the answer is actually quite simple. It's that a lot of our customers have private images as part of their proprietary information, and we don't want to by default give all of that available to the public internet, because once you know it's public forever. You can't ever take that back. So it's more of an opt-in than an opt-out. We are working on solutions where we can actually do this from AEM and not in the caching headers, to be continued. The next one I want to talk about here is HTML, and this one we do have in there as a default. And the default for HTML content is 300 seconds, or 5 minutes. And you might be thinking that's actually quite low. That's quite a few return trips back to the origin. And I'm going to talk about in the next slide the difference between invalidation and revalidation. So I'm going to revisit that. But the thing to note here is that especially for content that is changing quite often, 300 seconds would be the optimal value for your cache ratio and revalidation. I'm going to talk about revalidation next. So two other things that I wanted to point out on these configurations. First, the location match. So if you can, and this is for both images and HTML, you can actually have different caching controls for different locations. So you can have, if you have very stale content that you know won't ever change, you can change that max age for certain locations. The other one is the set age, and we have this by default now set to age 0. And this is a result of a few very low cache ratios that we found from our customers that were in the 5 to 6% range. And what we found is that if the age value gets set too high, and if their age value is missing, there's a default is applied, and that value gets higher than what the TTL is on the CDN side. What ends up happening is the CDN thinks that everything's old and it never caches anything. So actually, in those cases, it's pretty impressive that they even got 5 or 6% out of that. But once we figured that out and put it in by default as H0, it skyrocketed back up. So be very careful if you're playing around with the set age values in the HTML content. Right, okay, so I want to go back to the invalidation versus revalidation. So as I said, the optimal value is 300 seconds or 5 minutes for revalidation. And I want to explain what the difference between invalidation and revalidation is. So it's very tempting for projects to want to publish their content and at the same time invalidate all the cache. It's essentially what's happening on the published dispatcher for the materialized view. Once it gets to the publisher, we're invalidating the materialized view. And it's very tempting to do the same thing on the CDN level. But it turns out to be a lot easier to do it by revalidation, and this is what we would recommend. And this is how it looks. So essentially, when you're requesting some content that has already expired, so the CDN already has it cached, but the max age has expired. So instead of requesting the content just flat out, which is what would happen if it was invalidated, all we're going to do is ask the origin, are we still good here? Is this still good? And then the origin can say, yeah, we're fine. We'll give you a 304 not modified. And now all we've done is a header back and forth. We're not sending the content back. We'll reset the counter on the content. And the key is here that we are actually serving this content from the cache. So we don't actually have to move the content all the way from the origin to all the different pops. And this can be really advantageous, especially when you're talking about images and you're talking about like large images or large resources such as client libs. Okay, so that covers all of the ways that we can, with the dispatcher configuration, get a better cache ratio. Finally, what I want to do is I want to cover some of the ways that we have self-service through our UI. And so we're adding more and more ways that we can do self-service to the Cloud Manager UI. But I wanted to highlight 2 different ones, and that is the custom domains as well as the SSL certificates. So with Cloud Manager, what you're able to do is you are able to configure your custom domains and manage them directly within the UI. So you don't need to open a ticket to Adobe. You don't need to open a ticket with whatever IT company is hosting your deployment, and you can manage everything in here. And this is all really well documented, and there's a slide that has all this, the link to the documentation online for the custom domains. The next one is the SSL certs. So it's the same thing. You can manage all of your SSL certs directly with the UI self-service. And this can be really powerful, especially because once you upload that SSL cert, it's going to be propagated through the entire system within a matter of minutes. And if you think about in an old model how that might work, you may have to open a ticket with whichever hosting company you have. Usually this is all happening as some sort of escalation because at the very last minute you realized you didn't have your SSL certificate and you're trying to go live. And as it always happens for every project, it's always either a VP or a C-level that was the one that noticed that the SSL cert isn't there. So you're definitely under a time crunch. And in this one, in a matter of minutes, you can actually get this out. Okay, so unfortunately, this is a very short time period in order to talk with you guys, and we wanted to leave a lot of time for questions. So I have a resources here for what we were talking about. The first link here is for the public documentation for caching, so everything caching. That's that is a must read. And then the second one here is the custom domains and the SSL certificates, which is what I just showed you there. And then from the very beginning, there's the New York Times article that I was referencing with the Microsoft and Google numbers, and it's actually a pretty good read. So you can check that out as well. So with that, I think what we will do, and how did I do on time? I think I actually nailed it. All right, so let's open it up for questions.
Shannon Erickson is saying, can certs be updated by API on CS? The answer is yeah. The Cloud Manager API, where certificates are updated, it's a API first user interface, and you can authenticate using an access token, a bearer token, and perform pretty much everything you can do in the UI via API calls. There may be one or two restrictions, but there's an API there for it. And I think even there's a public CLI built on top of Adobe I/O, which you'll find in GitHub.
There's a question asking about how they can actually get their cache hit ratio.
We intend to expose those stats. At the moment, those stats are not exposed. We have them internally, and we can produce APIs to expose them. What we really want to do is expose them inside Cloud Manager, so you can see them, and you can see the graphs inside Cloud Manager of your hit ratios and everything that we can, reasonably expose. We're going to try and do that, but it relies on that interface being in Cloud Manager. Yeah, and that's where we are at the moment for those hit ratios. Oh, the other thing actually on this subject, I mean, with the Lighthouse scores and various things like that coming out of the testing, you get a pretty good idea of what the performance of a site will be based upon that set of information. So running Lighthouse against the instances gives you an idea of where the cache hit ratios are going to be.
I'm just, everyone that I want to ask, you've already answered. So
sorry.
No, I mean, that's great. I'm just, I'm trying to play catch up. I know you probably, if you have one, just keep going. I'm almost to the bottom.
I mean, there's mention of the race conditions you get with CDN purging, which we're very aware of. We've built the structure of the CDN to be spec compliant. So once you got past that dispatcher, everything further out from there is spec compliant, because actually our origins are eventually consistent, our POPs are eventually consistent, and so consequently there is an issue with race conditions appearing where you've got new content at the origin, but it's not all new at the origin. How does so we've got one here from Domenico Crea. How does invalidation work? Is it possible to configure what to invalidate based on what has been published? I think this goes back, Mike, to your slide on. Did we have a slide on immutable URLs and revalidation?
Yeah, I mean, it was that was with the version client lids, but I don't know if that really.
Do we have the binary one? Do you have a diagram of the binary serving binary content?
So there's the version client lids, of course, and then there is the revalidation one. This one.
Yeah, that one.
Sorry, can you repeat the question?
So I mean, so the question was, let me find it again. How does invalidation works? Is it possible to configure what to invalidate on what has been published? And I think that actually comes down to revalidation with the right settings. So if you've done a surrogate control on the edge, which means that the edge is going to cache the content, regardless of how long you leave it, allow a client to cache it. You may not allow a client to cache it. Then with that revalidation on the edge, you can put it down at a very low level so that the TTL revalidate occurs every 30 seconds or every 10 seconds. But you'll also configure it to serve stale at the edge and to request collapse at the edge, which means that once there's a cache copy at the edge, there's only one request goes back to the origin. And if you've made the response to the unmodified since really quick, like you've got it cached in the dispatcher, then that can come back in less than a millisecond. And that allows you to actually have a very low cache hit ratio. So we've seen with some of our customers that we've got cache hit ratios up in the 90% area, and they're serving several thousand per second at the edge. but we're only seeing 1 or 2 per second hitting the origin, and all the content is fresh at the edge and never older than 30 seconds. And that's a pretty good strategy. It's not the only strategy, but it's a pretty good one that works really well with the dispatcher.
So there was a question about putting the URLs in the chat. I'll just leave this slide out for you. So Ian, there's one here from Roger. Is there a better solution or approach for handling SEO redirects or vanities at the edge directly from AEM as a cloud service, or a better vanity URL method?
So at the moment, we're not loading redirects at the edge. We're making it possible to load vast numbers of redirects in dispatchers and then configure how they're cached at the edge. So effectively, you end up, because one of the things we can do, we can definitely cache a redirect to the edge, and we can also follow a redirect at the edge, which we do quite a lot in order to follow to immutable content. So that allows you to do that very large volume, and it also allows you to ensure that those redirects don't necessarily have to be hosted in AEM itself.
Thank you all very much for your time this evening for me, and morning for those of you that are in the States and anywhere else that you are. Really appreciate it.
Thank you.
Bye, everyone.
Bye.